Good afternoon, everybody. So just a quick announcement. Over the weekend, I updated all of the assignment due dates, so you can actually see those now on OnQ. Quiz dates are the tentative quiz dates that were posted on OnQ, so those are set now as well. And I guess that's it. You have an assignment due Wednesday night, I think, or Thursday night or something, I don't remember. Sometime this week. But don't forget, you also have the universal extension if you need it. I think you actually do need some stuff from today's lecture to finish the assignment. I think there's a couple of questions that require you to change some permissions. So that information will come in this set of lectures. All right, so in the last class we were talking about pipelines, right? So in Bash you can have a command. It outputs stuff to standard output, right? So in other words, it outputs some text. Right? And many Bash commands take text as their input. So you can redirect the output of one command and send it to the input of another command. Right? So redirection allows you to send output of a command to a file. Right? Piping lets you send the output of a command to another command. Now the question is what happens if you need to do both? Right? So I need to redirect, or I want to redirect output of a command to a file, but I also want to pass that output down to another command, right? And so the answer is, can you do both? The answer is yes, right? But you have to do it in a particular way. So the mechanism that passes, that sends output to a file and also sends the output further down the pipeline is called a T. And the T is just another program, so it's just a command. Right? So the T command reads standard input, right? So takes as input anything going into standard input, copies it to both standard output, right? So in other words, it passes it down the pipeline, and it writes it to one or more and redirects it to one or more files, right? So the reason it's called a T is because it kind of looks like a T in the pipeline, right? So in other words, anything that goes into its input also goes out to its output unchanged, right? But it also redirects a copy of that to some file. Right? And so the T command is useful for saving intermediate results of a pipeline to a file or files. What you have to be very careful not to do when using a T, right, is to take the output of a T. So that right here, so when you say T followed by some file name, right, that redirects that redirects its input. It sends a copy of its input to the file that you specify. Right? But you don't actually know when that file will be written to. Right? So there's no guarantee that the T writes the full date, right, before the next command happens. Right? And so what you must not do is you must not use a command later in the pipeline to read the file that was redirected earlier by a T. Right, because you don't know when that file when the file will be completed, when the file will be fully written. So the command that's further down the pipe might run before the file is written. Right? So if your command down the pipeline needs that file, it won't work properly. All right, so here's a sequence of commands that hopefully illustrate the pipeline and the T, and this new command that we haven't seen before called cut. Right. So the date command outputs the date. Right. So if we just run that on Macs, date will output something different than you see there. So the default date command on Mac is different than the one on Linux. Right. Now we know that I can take the output of date and send it to a T. Right. So I can send it to the T full date.txt. Right. So run the program, pipeline, and pipe the output to T. Right? Now remember what T does. T redirects its input to a file called full date, but it also sends a copy onto further the pipeline, further down the pipeline. Right? So in this case, you actually get the output of date, right? Because T actually prints that output, right? Sends it further down the pipe, which just goes to standard out. However, in this case, it also sent it the output of date to the file called full date. Right? So if you look at full date, right, it's also, the current date. Right? Okay, so that's that line right there. Now the next line, right, it's the same thing, but it extends the pipeline, right? So it takes the output of date, right, and now uses the cut command to split the output. Right, so let me just run the command first, and then we'll explain what it does. And let me just make sure I get this right. Okay, so cut minus delimiter. Whoops, so there's my, right, so extend the pipeline, pass the output of date to the cut command, minus delimiter, delimiter. What am I using? The delimiter is the space, right? Yeah. So the delimiter is the space character, and the field that I want is number 1. Right? Okay, so what does cut do? So cut takes data or text that's arranged in columns and isolates one or more of the columns. Right? So by column, I just mean that it's split into columns. Well, so yeah, by columns, I mean it's split into columns, but the splitting happens on some what's called a delimiter character. Right? So here, the output of date is Monday, right? January 23rd, blah, 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 blah. Right? So we can imagine that that's 6 columns of output, right? The date followed by space, then the month, the day, the time zone, and the year. Right? So here, this, we can imagine that's 6 columns. It's 6, right? 1, 2, 3. Yeah, 1, 2, 3. Yeah, 6 columns of data where the columns are separated by a space. Right? And so the cut command will let you pull out different columns. Right? So here we're telling cut, use the space as the character that's separating columns. Right? And then here, this says pull out column number 1. So it calls the columns fields. Right? So that will pull out the day. Right? If you want to pull out the month, that's just field number 2, right? And if you want to pull out the year, I think, yes, the year, that's field number 6, right? And you could also use the abbreviated options, right, instead of using the long options. So minus D is just the short form for delimiter, and minus F is the short form for field. And you can also pull out ranges of fields. Right, so date, so minus D, space, minus F. Let's do 1 through 3. Right, so I can pull out fields 1 through 3, and that gives you Monday, January 23rd. I believe you can also use a comma separated list here, if I remember correctly. So 1, 3, and 6. Oh no, I lied. Okay, so you can't use the comma separated list. Right, so I think there is a way to specify which fields you want exactly, rather than just having to use a range. But we can always look up man for it, right? So, boop, boop. Okay, minus F, it is a list. Select only these fields. Also print any line that contains, okay, fine. And so what is your list separated by? Each range? Yeah, I thought you could. Separated by commas. For each list is made up of one range or many ranges separated by commas. Selected input is written. Yeah, I thought that's how it worked. So what did I do? 1, 3. How about 1, 6? Monday 20. Okay, that's how that works. What did I do? Did I get it right? Oh no, I did get it right. So never mind. It was right. 1, 3, 6, right? Monday, January. Yeah. Sorry, I'm being a dummy. You can use commas to pull out the individual fields. And so there's, oh, and if you look at the, cat full date, right? And when you look at the file full date, right, that's always the output of the command that was the input to T, right? So it's always Monday, January 23rd, something, right? You can pass on that output further down the pipeline to a program like cut to process it further, right? And of course, if you wanted to, you could have something after the cut. You can add in extra T's. You can do whatever you want. Right? So you can insert a T after any command in a pipeline to record all of the intermediate outputs if you desire. Right? So I can take fortune, right? I can take its output, send it to a file called fortune.txt, right? Pass the output of fortune to cowsay, right? And then send that output to cow.txt, right? And then pass the output of cowsay to another cowsay program, right? So I'm going to have a cow output another, whatever another cow is saying.
Is there a way to do it without having two T's? Like, could you just have one T with the two texts?
So you want to do fortune and then pipe.
T them together. Like, I want to do the way we did there, but instead of having it in two separate T's,
Yeah.
I do it in one.
You can do. You can't get the output. So the first T gets the output of fortune.
Yeah.
The second T gets the output of cowsay after, which got its input from fortune. Yeah. So you're getting. Yeah. So you're gonna. So let's just run this and you'll see the difference. And I'm gonna hopefully copy and paste this and get it to work. There we go. Okay. Cowsay. Oh, sorry. There's an extra space there. Okay, so that's what it should do, right? So we take fortune, right, and we're going to output the fortune to fortune.txt. So fortune.txt is just going to contain the don't tell any big lies today, right? I'm going to take the output of fortune and send that to cowsay. So that's that cow right there, right? I'm going to take that output and send that to cow.txt, right? So there's the first cow, right? And then I'm going to take that output from cowsay and send that to another cow, right? And that's how you get the, and that's the overall output right here, right? So the T's are useful if you need the intermediate outputs for some reason, right? But remember what you must not do, right? So you can save the intermediate outputs, but you cannot process the intermediate outputs in the same pipeline, right? You have to do it in a separate list of commands after you run the complete pipeline, right? And that's because of the way the pipelines work, right? So remember, in the pipeline, each command, you don't know when each command actually starts running, right? So it's possible for a command that's later in the pipeline to start running before the output from a T is written, right? And so you're not guaranteed to get the correct output in that case, or to compute the correct result in that case. All right, so that covers everything that we need to know about pipelines and T's for the time being. Right. Any questions about them? It's a relatively simple concept, but it lets you make, assuming you know what all the assuming you know what commands you want to use, setting up pipelines is very powerful. So you can set up very long, or very powerful pipelines just by taking the output of one program and sending it to another. Okay. So files are fundamental to the Unix file system, right? Everything is there's even a saying that everything in Unix is just a file. Right? And so Unix file systems, Unix-like operating systems are designed, they're not like a Windows, they're not like your normal computer desktops, right? The original intent for these things was that they were these multitasking, multi-user systems, right? So that is, it's a file system, it's an operating system that supports many concurrent users at the same time. Right? And that used to be the way that the labs in the computing science department were set up. Right? So you would go in and you'd sit down at a terminal. You'd sit down at what looks like a computer, right? So you'd have a keyboard and a monitor, but all the computation was actually happening in some room somewhere, right? So you were just on this little box that was networked to an actual computer, and there'd be a whole bunch of people in that room, right? And they'd all be accessing the same computer at the same time, right? Which is very different than how most of us use our desktop computers, right? There's only one user at the same time. So you can have more than one user of the computer at the same time. Typically, the users are logged into the computer over a network. Now, for this to work, you need mechanisms in place that basically that protect the users from one another. Right? You also have to protect the operating system from normal users. right? Because you don't want some user to like delete part of your operating system and that crashes it for everybody. Right? So, for example, a user should not be able to, should not be able to modify or perhaps even see other users' files. Right? Remember, there's lots of potential users on the system at the same time. You don't want them. You probably don't want everybody to be able to see everybody else's files. Right? And a normal user should not be able to modify critical operating system files. Right? Okay, so Unix provides what are called permissions to separate users from one another. Right? So first of all, there's the concept of an owner. Right? So a user is allowed to own files and directories. Right? So on your Linux setups or on your Mac, right, you own your home directory, right, and all of the files on your home directory. So of course the owner has control over access to their own files, right? Which means it's possible for the owner to grant access to other users, right? And so there's a granularity to how users are grouped, which I'll explain in a moment, right? So it's possible for the owner to grant access to a file to all other users, so that's the world, right? Or they can grant access to groups of users, right? And so there's this notion of individual user, groups of users, and everybody on a Unix system, right? Now the problem with the groups is that an ordinary user can't create groups on Unix, right? So the only one that can create a group is what's called a system administrator. Right, so someone who actually has what are called super user privileges. Right? They're the ones that can actually, they're the ones who can actually modify operating system files. Right? On your own computer, you're probably a super user, right? You're probably a system administrator. Or you're able to get system administrator privileges. Okay, so the ID command provides information about a user's identity. Right? And so the output, it depends on your actual operating system, right? But if you just type ID into the shell, you'll probably output the name of your username on your computer. Right? So if I type in, Control L, ID, right? It spits out a bunch of information, right? UID, so that's the user ID. You can see that's me, right? GID is the group ID. Modern versions of Linux are funny. Every user also gets a group named after them, right? So the user ID here is me. Group ID is also me, right? And then you can see there's a bunch of groups that I belong to, right? Exactly what all these do, not important, right? If you type in someone's username, right, you can find out information about that user. I think Homer Simpson's a user on my computer here. Yeah, so Homer is a user on my computer here. It's just a made-up directory. It's just a made-up user, right? So you can find out information about particular users here. Okay, so a user has control over 3 different access rights for their files, right? Remember, directories are also files. So the user can specify who gets read access, who gets write access, and who gets what's called execution access, right? So read access, if it's a read, write, and execute mean different things if the file is a file or if it's a directory. So for regular files, if a user has read access on that file, that means that the user can open the file for reading. Yeah, they can read the contents of the file. If the user has write access on the file, then that means the user is allowed to write to the file or truncate the file. That means delete the contents of the file, but not the file itself. Right? So having write access on a file does not mean that you can delete or rename the file, which makes sense if you remember exactly what a directory is. I'll explain that in a second. Right? And so execute permission means that the user is allowed to treat the file as though it were a program and they can run it. Just because you set execute permission on a file doesn't mean it's actually executable, right? So you can take like a .java file and turn it into an executable and turn the execute permission on. You can't actually run it without compiling it. Okay, what does it mean if you have read access on a directory? Right? So if you have read access on a directory, that means you can list the contents of the directory. Right? In other words, you can run ls. Right? As long as you also have execute access on the directory as well. Right? So execute permission on a directory means the user can change into that directory. Right? So in order to list the contents of the directory, you have to be able to change into the directory, and you also need write permission on the directory. All right, so this is the funny one right here. So you would think that if you had write permission on a file, you could rename the file, right? Or you could delete the file, right? But remember how file names are stored on a Unix file system, right? So your file names, right, are not part of the file itself, right? So remember what a directory is in Unix or Linux, right? So a directory is just a file, right? In one column, it's the inode ID, right? In the second column, it's the file name, right? So that's what the contents of a directory are, right? Just a file, inode, file names, right? So in order to delete a file, you have to be able to edit a directory, right? So in order to delete a file, you need write permission on a directory, not the file itself, right? If you have write permission on the file itself, you can change the contents of the file, right? You need write permission on the directory in order to actually remove the file, right? Because you need to go into the directory and delete the file name, right? So if you have write permission on the directory, that's when you can create, delete, or rename files, as long as you have execute permission on the directory itself. Okay, how do you make a directory? The command is called makedir, mkdir. Right, so makedir creates a directory. So let's just go back here. Okay, so ls, so I've got some, I'm going to delete cow, fortune, and full date. So cow, fortune, full date. Okay, so all I have here are the directories, assignments, lectures, and notes. Right? I can make a directory. I can call it whatever I want. Right? dir1. Can't have a colon in it. You can't have a colon in a directory name. Otherwise, I think you can have anything else. If I type ls now, you'll see that there's a directory called dir1. Right? Can you make a sequence of directories? Right? So can I make dir1, and then inside dir1, make a directory called, I don't know, x, and then inside x, make a directory called y. Right? So in other words, can I write dir1 x, y? Right, so can I make a whole sequence of directories? Right? And the answer is no. Right? So cannot create directory dir1 x, y, no such file or directory. Right? And so the problem here is that what this command is trying to do, it's trying to make the directory y. Right? That's inside x, which is inside dir1. Right? dir1 exists, but x doesn't exist. Right? So that's why you get this funny no such file or directory message. Right? If you want to make a sequence of directories, though, you can. You just have to pass in an option to make dir. Right? So -p means make all of the parent directories if necessary. Right? So that works. Right? So if you put in the -p and dir1 doesn't exist, it makes dir1. If x doesn't exist in dir1, it makes x, and then it makes y. Right? So if I ls dir1, there's a directory called x. Right? And if I ls dir1x, there's a directory called y. And of course, there's nothing in y, right? Because we just made that directory and we haven't put anything in it yet. Right. Okay, if you want to see the permissions on a directory or file, then one way to do it is to ask ls for it. Right? Oops, sorry. But when you ask ls, you need to pass in the L option. Right, which is the long format option to ls. You have to be careful with the long format option. So ls minus L. Right, and now you get more information about every file and directory in the current directory. Right? When you use -L, there's no documentation for the output that you get, which is strange. So there's no standard for what -L lists. Typically, what it lists is something like that. right? But if you go from operating system to operating system or from shell to shell, you can get slightly different output everywhere you go. So whatever you do, don't try to parse the output of ls to get information about files, right? It's not guaranteed to work, or it's not guaranteed to make your command portable. All right, so we need to figure out what all this stuff is, so let's take a look. Right. Okay, so if I do ls -l file1.txt, for example, right, that will list the long format listing for the file, right? And you see there's made up a bunch of stuff here, right? Okay, so that first symbol in the output, right, is typically the file, what's called the file type. Right, so I'll describe the file types in a minute. Oh, actually, I'll describe right now, right? So if you see a hyphen in the first place, at least on Linux, right, or on this particular version of Linux, right, it's just a regular file. If you see a D, it's a directory. If you see an L, it's a symbolic link of some kind. Right? We haven't looked much at symbolic links. I showed you a little bit how bin is a link to user bin, but we haven't seen much. We haven't seen them in any detail yet. You won't see C or B unless you go poking around in your operating system files. Right? So C is what's called a character special file. So that's just a device that handles data as a stream of bytes. Right? So in other words, a terminal. Right? So there is actually a file on your file system that corresponds to your terminal. Right? And that's how the operating system writes stuff to your terminal. Right? It just sends it to a file. And there's something called a block special device, and that handles data as blocks of bytes. So that's something like your disk drive. Right? So again, if you go poking around on your operating system, you can find a file that corresponds to each one of your storage devices. Right? They'll have a B in front. All right, the next three symbols are the user's read, write, and execute permissions belonging to this file, filed1.txt. Right? So if you see an R, if you see an R, that means the user has read permission. If you see an W, that means they have write permission. And in the in the next place, if you see an X, that means they have execute permission. And if you see a hyphen, that means that particular permission is not granted. Right, so you can see here, I have read, write, but not execute permission on file1.txt. Right? The fact that there's no execute permission means I can't run file1.txt as though it were a program or a command. That's all that means. Right, so the first three are the user permissions. The next three are the next three are the group permissions. Right? So the group, whoever's in the group Burton, right, they would have read permission on this file, but they do not have write, and they do not have execute permission on that file. And then finally, the last three are the world, so everybody else, right, or everyone is the other way to think about it, right? So everyone has read permission on that file, right? They do not have write permission, and they do not have execute permission on that file. Right? And you can set each one of those 9 things separately. Right? So you could do something nonsensical, right? Like take away read, write, and execute permission from the user, but give read and write access to everybody else. Okay, that number there, at least on my operating system, is what are called the number of hard links. Right? A hard link is just a directory entry that associates a file name with an actual file in the file system. Right? So when we're talking about file systems, we briefly visited the hard link issue, or what hard links were. Right? If you need to, if you're still not clear about them, go back to the file system or the files notebook, and it explains what hard links are in greater detail. Right? Every file needs at least one hard link, so that number there is always at least one. Right? So in other words, there has to be an entry in the directory for file1.txt. Otherwise, the file doesn't exist. Right? So that number there is always 1. It can be more than 1. The next field is the username, or the owner name, sorry. The next field is the group name. The next field is the file size. File size usually not in human readable. Not in human readable units. That thing there is either the modification time or the creation time, right? So in other words, it's the time when you last edited the file1.txt, right? And then finally, that last thing there is the file or the directory name. Okay, if you need to change, or if you want to change the permissions of a file, then the command that does so is called chmod, right? So change mode. Change mod's weird. There's two different ways to use it. So you can either specify the permissions using numbers, or you can specify them using symbols, right? Okay, so number one is specifying permissions with a number, right? So you specify what's called an octal value, right? So base 8 number. So base 8 is just the digits in a base 8 system are just the digits 0 through 7, right? All right, so if you look at the octal value 0 and convert that to binary, right? Then in binary, that's just 0, 0, 0, right? The octal value 1 is just 0, 0, 1 in binary, right? And 7 is all ones in binary, right? So if you can remember how the octal values map to their corresponding binary values, then you can easily figure out what these mean as far as the permissions go, right? Anywhere there's a 0, right, it means you do not have that permission. And anywhere there's a 1, it means you do have that permission, right? And it's in the order read, write, execute, right? So 0, 0, 0 means no read permission, no write permission, no execute permission. Right? 001 means no read, no write, but execute, which doesn't really make any sense. Right? 010, no read, write, no execute. Right? And so that's so they use the octal value as a short form for the binary value. Right? 111, all permissions for the are given. Right? So read, write, and execute permission are given. So for example, right, if I write change mod 400 file1.txt, what does the 4 mean? So you just go back to the handy table here, right? So 4 means 100, which is read, no write, no execute, right? So for the user, right, the user gets read permission, write permission gets removed, execute permission gets removed, right? 00 means for the group, take away all permissions. And for everybody else, also take away all permissions. So let me just go in and make up a file, touch. OK, so there's a command called touch. Right? So touch and then a file name or file names. Right? So what the touch command does is it updates the modification time of a file. Right? If the file doesn't exist, it makes an empty file with that name and then sets the modification time to the current time, right? So if I press enter and do ls minus l, right, you see that a file called file1.txt appears, right? It has its modification time is the current time and it's empty, right? If I touch, let's see dir1. So dir1, right, so its modification time was 153. So if I touch dir1, right, that updates its, that updates its modification time to the current time. Right, so touch, update the modification time, or create the file if it doesn't exist. Right. My permissions on file 1 are here. Right, so I have read, write, not execute. Right, everybody else has read permission. So if I do change mod 400, file1.txt, right, now you can see that I have read permission and no other permissions, right? No one else has any other permissions as well. Right, 444, give everybody read access. So change mod 444, file 1, and then, right, so now everybody has read access. 755, so give me all permissions. 5 and 5 are read write, I think. Read RX? I don't remember. Let's take a look. Change mod 755. Ah. Read and execute permission, right? So I get all permissions. Everybody else gets read and execute permissions on the file. Notice that when you set the execute permission on the file, it shows up in green. If you have the, well, on my particular setup, it shows up in green, right? It's to indicate that this file is an executable file, or at least its execute permission is turned on. It's not actually executable because it's empty, right? But it's indicating that its execute permission bit is turned on. Oop. Okay, so the numbers are easy to use as long as you can remember what they mean, right? I think it's safe to say that most system administrators probably use the numbers because they're doing this quite often. If you don't do it so often, then it might be slightly easier to use the symbolic notation. Right? So with the symbolic notation, you can specify whose permission you're changing, right? Using U, G, O, or A. Right? So U is user, group is group, O is other, anybody that's not group or user, right? And A is everybody, right? So A is all, right? And then you can say, do you want to add a permission, right? So plus. Do you want to take away a permission, minus? Or do you want to assign a permission, equals? Right? And then you can say which permissions do you want to add, take away, or assign with RWX. Right? So for example, change mod plus R. Right? That means that's the same thing as A plus R. Right? So that means for everybody, right, add read permission. Right? The other permissions remain unchanged. Right? So if someone has write or execute permission, those don't change. Right? Plus means add, right? But don't change anything else. Right? U plus W means for the user, add write permission. Right? U minus X for the user, remove execute permission. Right? And then A equals RWX means assign read, write, and execute permission for all users on that file, right? And you can split them up, right? So for the user, I can add execute permission, right? And then for the group, I can assign read and execute permission on that file, right? So I'm not sure which one's easier to use. I tend to fall back on this format, but if you can remember the numbers are slightly, I mean, there's slightly less typing involved. Okay, expand, oh, what time is it? Expand, 2:08. All right, so I've touched on this a little bit already. So when Bash has these things called expansions, and there's a bunch of them, right? We've seen a few of them. So you've seen tilde, right? Tilde is an expansion, right? So we've seen that already, right? Remember I told you that corresponds to your user, your home directory name. Right? So an expansion in Bash is something that replaces something else that you've typed in. Right? So when you type in this, right, the shell expands that to your home directory name, right, to the absolute path of your home directory name. Right? And so what the shell actually does is it replaces that character with root home / Burton in my case, right? And so that's why they're called expansions, right? So that thing gets expanded or replaced with something else, right? The wildcards, like star, those are expansions, right? That's called file name expansion, right? So when I write ls star in a directory that has these 3 files here, right? That star gets replaced with that file name, that file name, and that file name, right? Because remember, star matches anything, right? Any string, right? So it matches a.text, b.pdf, and c.out, right? And so when the command actually executes, it's the bottom command that executes, right? So the expansion occurs, then the command occurs, right? So the process of performing the substitutions is called expansion. An expansion involving wildcards is called path name or file name expansion, right? That's called tilde expansion. Okay, so this command echo that we've used, we've seen a little bit, right? So echo prints its string arguments to standard output, right? So in other words, echo space and then one or more strings, right? Echo just prints those strings to the standard output. Right? So this is one way of printing stuff, right? So echo, this is an echo. Right, so echo is one way of printing a string to standard output. Okay, so path name expansion occurs before the command is ever executed. Right? So if I've got a bunch of files here, right? So file 2, file 3, and fruit apparently. Touch file 1, file 2, file 3, and fruit. .exe. Right, so I've got a bunch of files that begin with the letter F. Right. Echo F star. So what's that going to do? So echo F star. Right. So what does the F star do? Right. So F star means, right, match all files or expand to all files in the current directory that start with an F. Right. So that expands to, sorry, hang on, ls, right, echo F star. Okay, so the F star is going to expand to file 1, file 2, file 3, and fruit.ext. I spelled it wrong, but that's fine, right? So it all gets expanded into a string, and then echo prints the string, right? Echo file question mark dot txt. Right, so echo file. Oh, it's file, sure, question mark dot txt. Right. So what does file question mark dot txt expand to? Well, there's a file called file1.txt. Right. The question mark matches the 1. So file question mark dot txt expands to file1.txt. Right. That's just a string. Right? You have to remember when it expands, it's just the name of a file, right? Which is just a string. So when you echo it, it echoes the file name, right? It doesn't echo the contents of the file, right? It doesn't print the contents of the file. If you want to print the contents of the file, that's cat, right? Echo fr. Okay, so fr star, well, that matches fruit.ext, right? So you're going to get the string fruit.ext, right? And finally, one more, right? So g star. Okay, so there are no files that begin with a capital G in this directory, right? So g star doesn't expand to anything, right? So in other words, the star doesn't expand, right? Because it doesn't match anything. So what you end up with here is just the string g star, right? Which may not be what you intended, depending on what you're trying to do, right? If you're ever using stars or question marks in this context, you're probably trying to match file names, right? If the wildcard expansion does not match any file names, then you end up with the expansion. You end up with the string with the wildcard in it on its own. Right? Which probably isn't what you wanted. So you have to be a little bit careful when you use the wildcard expansions, right? The file name expansions. Right? Oh, okay. So there's a lot more to say about expansions, but I think I'll save that for the next day. So I think there's, I don't remember, 7 or 8 different kinds of expansions. They happen in a particular order. You have to remember that they're all happening, right? You have to remember that these things are all happening when bash is interpreting your commands. Otherwise, nothing makes sense. Everything looks really strange. All right, so we'll pick this up in the next class on Wednesday.